Yeah, thank you all for resisting the draw of agentic AI to be here with us and listen to two guys from Switzerland talk about money. I've been told it's very cliche, but it was too late to change the presentation to a different topic, so money it is. We will be talking about getting your Kafka costs under control, or not really getting them under control, but more making somebody else pay for your Kafka, which is really the essence of what this is. Before we begin, one short slide about who we are. I mean, our ceremony master you already know from today and from yesterday, but I will still hand over to Ralph to...
I didn't. So I'm working for Migros, a big Swiss retailer, and Alex.
Oh, that was fast. Okay, yeah, I'm Alex. I work at SPOUD, which is a Swiss-based consultancy. We do a lot of work around event streaming, event-driven systems, everything that has to do with events, which in Switzerland apparently means doing Kafka. If any of you as a consultant in a different country, I would love to hear from you what your experiences are. We at SPOUD, most of the work we do is really around Kafka. It seems to be the leading product there. And over the past 2.5 years, the clients that I have been working with, those clients are pretty early on their event streaming journey. And so the stuff I ended up working on most of the time was something you could call platform engineering. So as a platform engineer, it was my goal to kind of build a platform that teams at the client can then use to implement their awesome event-driven solutions, to make their visions of streaming data analytics a reality. We had a very interesting keynote yesterday, if you went to the main conference, about platform engineering. And I mean, I can't possibly compress all that into one slide, but something that resonated with me from that talk were the pillars of self-service, abstractions that make sense for your organization, right? Because we cannot compete with AWS, we cannot compete with Azure when it comes to features, when it comes to the offering as a small team. But what we can do better is build bespoke platforms that make sense, that work well with everything else that is already going on at your company. And that also goes for integrations with existing software, right? Like if you use HashiCorp Vault to store your secrets in your organization, then a good Kafka platform would also put like all your API keys that you need for talking to Kafka into the same secret storage, for example. And this presentation here is about one pillar that, in our opinion, is frequently forgotten, frequently neglected when building platforms, and that is the billing. And in my opinion, billing is especially important, especially crucial when you are building a Kafka platform, or when you're trying to integrate Kafka into an existing platform. And the reason for that is simple. Kafka is expensive. Okay, we have clients which are, as I said, early on their event streaming journey, and they are already paying 5-figure bills every month for their Kafka usage. And as more and more teams onboard themselves onto Kafka, this is just expected to go up and up. And the reason why Kafka is so expensive is, well, there are multiple. Well, first of all, you have to pay for the number of brokers. Kafka is not just one server, it's typically a cluster. It is a distributed system. And the smallest cluster that really makes sense is a cluster of 3 brokers, which already means you have 3 processes, 3 servers, 3 virtual machines that are running somewhere on your infrastructure or in the cloud. You have to pay for the memory, you have to pay for the compute. The biggest cost driver, I would say, is the network traffic, because Kafka is, as I already mentioned, a cluster. That means you produce data to one broker and somehow it all gets replicated. It doesn't stay on that one broker. That would be quite disastrous for durability. If we lost that one broker, we would lose all the data on that broker, and that's why when you produce 1 gigabyte of data in reality, you have just incurred 3 gigabytes of network cost, because that will then get replicated to 2 other brokers under standard settings. You can also, of course, increase the replication factor if you wanted to, or decrease if you feel adventurous. Of course, Kafka is a big data system, so you will be storing a lot of data in your Kafka cluster. And also, if you use a cloud provider like Confluent Cloud, you will be billed for the number of partitions that you have in your cluster. And if you have many topics, you are bound to have many partitions as well. And all this is just Kafka on its own. If we want to have a platform, we need additional surrounding components. Yesterday, we had an interesting talk where the speaker said that we should treat our events as an API. And the thing that I like about APIs is that I know what to expect. There is a schema. I know what shape my request should be, and I know the shape of the response I'm going to get. And to have the same thing in Kafka, you would need, for example, a schema registry. And this is an additional component you need to deploy. If you have it handled for you by a cloud provider like Confluent, they will bill you for every schema that you put on there. So that is an additional cost factor. And after you have done all of this, you still haven't even begun paying the salary of Ralph or paying my salary. So what I'm trying to say is it's an expensive platform. And that is why eventually we wondered, who is paying for all this? And after we looked around, we came up with this very sad Venn diagram. We found, at least at Migros, that there are those who pay for Kafka. That's a platform team, because they set it all up. Like, they went on confluent.com, they created the account, they entered the credit card information, and then they get the bill every month. But we don't really use Kafka as team data integration, where we are the team that provides this platform. We offer it as a service to the others in the company. But yeah, all the building happens here, which is the product teams implementing actual solutions. And I even spoke to one of the engineers from this world, and he told me, cost control? What costs? Infrastructure is free. This is especially like a sentiment I hear a lot from companies where there is on-premise infrastructure. Because if you have infrastructure in the cloud, AWS will tell you what that S3 bucket cost you, what that pod cost you. But if everything is running like in a data center right next to your office, it could be way less organized. And then you really have the impression that, yeah, if I deploy on-premise, it doesn't cost me anything, because I never see the bill. But of course, somebody else is always paying for that. So about a year and a half ago, Migros and SPOUD sat together with a goal to bring these two worlds a bit closer together, with the dream being, of course, to make them one circle, to create this perfect overlap where you have perfect usage-based cost distribution. If you use Kafka a lot, then you should pay a lot. If you use a little bit, then you take over just a tiny bit of the platform cost. Now, I think that is fair. It's already being done for other infrastructure components, right? Like, if you have a pod in your Kubernetes namespace, if you use volumes, if you use memory, you will probably see the bill for that. If you create S3 buckets and store 1 terabyte of data on there, you will pay for ingesting the data into S3. You will pay for retaining the data on there. And also for the egress, you will have to pay. So if it's already done for those components, why can't we, or why should we not do this for Kafka? The other reason why we should be distributing costs, why we should be passing these costs on to the product teams, is because it encourages teams to be cost efficient, right? If infrastructure is free for me, then I don't have a great incentive to be clever about how I use it. If my pod on Kubernetes is running out of memory, now I could go and look for a memory leak there, or I could just give it more RAM. It doesn't cost me anything, right? And this charade could continue, but at some point we have to look into the problems, we have to be smart with our usage, because the overall cloud bill will go up for the organization, even if we don't see it. So cost efficiency is definitely a reason. It also helps us as the platform team, when we collect these metrics, to know who are our big consumers, who ingest a lot of data through Kafka, who consume a lot of data. And if we have this information, we can go to these teams and also advise them on how to be smart, how to tune the consumers. We had this case at Migros where one team in particular was producing a lot of XML data, which was uncompressed. And the nice thing about XML, well, there's not many in my opinion, but one of them is that it lends itself well to compression. It is very redundant, which means if you just switch on compression on your Kafka producer, which you can do without changing the code, you will already drastically reduce the volume of data that you have to send over the network, which will reduce the bill for us. And if we do cost distribution, it will also reduce the bill for them. The other reason is transparency. I mean, it's literally on the title of this presentation. And what we mean by that is that if we collect usage metrics, then we can know who are our downstream consumers, who is producing what data. If I am a product owner and I know that there is 3 different teams that are consuming data that I produce, I would love to have that information, because I could go with this data to a budget meeting and I could claim that, hey, we are creating value not just for ourselves, but we're also helping with these other use cases. And then if we do cost distribution, I could say, hey guys, you're using our data product, you're consuming data that we produce. It costs us $1,000 a month to produce it. Why don't you help us out with those costs? This is an approach called cross-charging. So what we would like to have ideally is something that the big cloud providers kind of offer to you out of the box. Here is an example from Google Cloud, where you really have per project a breakdown of what it costs you to run your Kubernetes pods, what it costs you to store data. This is a screenshot I pulled from Google Images. I hope I did not leak anybody's data. I guess if it was already on Google, then it is leaked. But yeah, the problem is there is nothing like this in the Kafka ecosystem. I think for a very long time there was also nothing like this in the Kubernetes ecosystem, and they solved it by developing KubeCost to, essentially collect usage metrics and to pass them on to the users. And so about a year and a half ago, we decided at Migros to build a solution like this from scratch. And it's not entirely from scratch, right? You don't start with bits and bytes. There is already some information that you have. And what you have if you start without a solution is just metrics from your Kafka broker. So you have the amounts of bytes produced and consumed by principal. And the principal is, in the case of Confluent Cloud, for example, is a service account with an ID. So you will have a metric that tells you service account SA-123 has produced 1 gigabyte of data over the course of the last minute or so. You will have the same information for topics. You will also know how many partitions you have per topic. And the problem is this is all too low level. You know, I could tell my manager that, we have a service account with this cryptic ID, and it accounts for 1/3 of our ingest, and nobody would understand it. So what we would like to have is the same information, but now aggregated not by some cryptic service account, not by topic name, but by project, by application, or by team. These are things that people understand, things that have meaning in the real world. So in other words, we have the raw data, but what we really want is context. So the high-level approach that we decided to implement is to collect the raw metrics, the metrics that are quite uninteresting on their own. An example would be a metric here that says that account SA minus so-and-so produced 5 megabytes of data over the course of the last minute or so, and in cluster such and such. Now, the cluster ID also doesn't tell me anything. At Migro, we have several clusters. Off the top of my head, I don't know which one this is. And then we try to match these raw metrics to a context object. So in our solution, we have somewhere a store of context. I'm not sure if this is visible from behind the lectern. But yeah, in there you have contexts that can be associated. You can think of it as a database join, although it's not actually a join. It's a bit more complex than that. They can be associated with a metric. So in this example here, we have the service account SA minus so-and-so, and we have a context, and we essentially enrich the raw metric with the context for that service account. And all of a sudden, we know that the accounting team has produced, in the productive environment, 5 megabytes of data in the last minute, or however often we scrape this. Then after that, we can optionally add a price to this metric. So we can continue enriching in our data pipeline. If we already know that 5 megabytes of data cost 0.0004 Swiss francs in this case, we could put that information in there. But as we will see in Ralph's part of the talk, we don't have to do it here. We can do much more fancy stuff downstream. And then we aggregate this. We normally are not interested in per minute usage metrics. We aggregate it into typically hourly time buckets, and we write it to wherever we put our data for further analytics. Could be a data warehouse, a database, a monitoring system. And once we have the data in there, we can generate fancy dashboards, we can generate reports, bills, and so on. So we have spoken a lot about context, and I think it is really the key to this solution. But where does it come from? Well, it depends, as with so many things in life. It depends on your organization. It is up to you to define what the context should look like. But the overall shape is that you have a regular expression which describes which resources, so which topics, which service accounts this context pertains to. And then the context itself is just a JSON object which can contain arbitrary information. In this case, and at Migro, we are interested in the application, so we want to distribute costs on an application level, which means that, well, in this example, for instance, if we had a topic like org, prod, app, metrics, views, it would match this regular expression, and then we would essentially substitute parts of this regular expression into the application field, and we would know that application org app metrics is the one that is associated with these measurements. So this was very abstract. The way it looks in practice is that we have Telegraph, which is a metric collections agent. Maybe you know it if you do InfluxDB, for example. It's from the same company. And what this agent does is essentially scrape metrics from Kafka brokers, from the Confluent Cloud Matrix API. And once we have these raw metrics, what we do is we ironically push them right back into Kafka. We write them into a Kafka topic. And once we have these metrics in the Kafka topic, we have the aggregator, which is really the heart of our solution, which reads these raw metrics and does the whole data enrichment pipeline that was described earlier, and writes this data out as aggregation. So now we have per hour usage data for each application. And then further downstream, this is something that is not necessarily needed, but is done at Migro, is that we sync this data into a database, in this case a Postgres database, and then we can generate Grafana dashboards. We have a monthly Jupyter notebook that is executed to generate a bill based on which the cost distribution is done. And before we move on with the visualization, with an actual example of a Grafana dashboard, a few challenges that we encountered, which I think are inherent to the mission and not so much to the company itself where we did it. We have to produce context retroactively for all topics and users. So if it is difficult to bolt on a cost control solution when you already have a platform going, when you have hundreds of topics, hundreds of users. Something we had to learn the hard way. But luckily, if you have a naming convention where inside of the topic name you have, for example, the name of the application, then you could potentially save yourself much of the trouble. It is also often unclear who owns what. Maybe in your domain, if you do DDD, it's less unclear because you have these bounded contexts and the topics will be inside one context or the other. But where it gets difficult is when you have cross-application topics, so topics that are used to make data available from one application to the other. Then it gets political, because you go to a team and you ask them, hey, do you own this? You are producing data in there. And they will tell you, no, but we only produce that data because that other team wants this data. So they own it. They should be paying for this topic. I'm a software engineer. I can help you with technical problems. I do not currently know how to solve political ones. So I will leave it at that and move on with the technical challenges. One of the issues we encountered is that even when we have the metrics from Kafka, we don't have all the data we would like to have. In Confluent Cloud, we know which account is producing how much data. We know how much data it is consuming, but we do not know from where. We do not know from which topics. If we are using an on-premise Kafka setup, then we don't know who is producing and consuming how much. We just know how many bytes are coming into a topic, how many bytes are coming out of a topic. So if we have an on-premise setup, we have to kind of center our cost distribution around topics and who owns them and pass costs based on that. And in Confluent, it's kind of the opposite. We have to center it around service accounts. We can sometimes employ heuristics that help us to fill in the gaps in our knowledge. For example, we can use permissions to determine where are these writes coming from, right? If we know 1 gigabyte of data is coming into this particular topic, and we know there's only one team that has permissions to write to this topic, then we can safely say, okay, they must be the ones that are producing this data. It gets tricky, however, if a topic is shared, again, by multiple applications or multiple teams. So in the end, when designing a cost control solution, we kind of have to look at what is our deployment, what are the metrics we can get out of there, and work around the limitations. One slide that I added on a very short notice is this one, the KIP 714. I'm not sure if you have heard about it. It's a very recent feature in Kafka. It was introduced with Kafka 3.7. I guess it's not so recent anymore because we're now at Kafka 4. Is anybody already using Kafka 4 here? Yeah, neither are we really. I guess if you use Confluent, then maybe they are already upgraded. It's not so clear. Yeah, so what KIP 714 does, it allows the Kafka broker to fetch metrics from the Kafka clients. And that is a goldmine because all the information that you really would like to know, like where am I producing, from where am I consuming, how much, and so on and so forth, the clients have all this information. And if you could scrape the metrics right from the client, then all of the problems I mentioned on the previous slide would not exist. But we have spoken about this with many of our clients, and the moment we say, yeah, we have to monitor every application in your organization, they'll be like, forget it, not going to happen. Now with KIP 714, the spyware that collects these metrics and sends them to Kafka is built into the Kafka client. So you don't have to configure anything, configure any scrapers. As soon as you connect to use Kafka as a client, you are simultaneously also sending telemetry data to the Kafka broker. And then if we have access to the Kafka broker, which we do because we are the operators, we can collect this data and we can do cost distribution. Again, unfortunately, this is very new, so right now it's not really in the system, but it is definitely on the roadmap. It also requires you to have a Kraft setup. So if you still are running Zookeeper with your Kafka cluster, then This is unfortunately not an option, but Zookeeper is end of life anyway, so I guess if you still do run Zookeeper, not for long. And now we come to the part where I show you a brief demo of a visualization of the usage data that we collect. So we have here a Grafana dashboard. Let's first look at the last 12 hours. So what we see here is the breakdown of the test environment at Migros by team. So in this case, we aggregated by team. The partition numbers are not so interesting for us. If we look at the production, we see one team. I had ChatGPT replace all actual team names with animal names and adjectives. I think it's ironic that the vast elephants are also completely dominating the production. At least, like, this is the data for the past hour. And yeah, on the test environment, they are completely dominating. We also see this on a per hour basis. So for the past, I don't know, since 6 in the morning, the vast elephants they completely took over this Kafka cluster, at least when it comes to ingesting data. And if you look at the consumption, it is more varied. But this is the kind of data that tells us as the operators, who do we go to, who do we talk to. Like, there is a lot of tuning that could probably be done for the vast elephants to make them less vast. But we don't know that unless we collect the metrics data. We could also zoom out, let's say, look at the last 7 days. And yeah, it's not really changed. The vast elephants are still dominating. But you also see these brisk snakes here. It's all generated by ChatGPT. It's not a comment on how I feel about the teams generating this data. For me, it's fascinating to see this as an operator because I can kind of guess what are these applications just by looking at the usage patterns. Like the brisk snakes, they always appear at 1 in the morning every day, and then by 6 in the morning they are gone. So it could be like some kind of Spark job. It can be a scheduled cron job that does batch processing, consumes en masse from Kafka, and then stops consuming by morning. And then I guess the vast elephants, it is a bit hard to explain. I can explain it. There is one team that has been using Kafka at Migros for years, and they are now migrating to Confluent, and they are moving all of their data from, I don't know, how many years now? Almost 10 years. Yeah. 9 years by now. Yeah, so, and I guess they're also moving data to test their migration. So, yeah. So much for the demo. And until now, we have only seen the usage metrics. Now it would be also interesting to see how you actually turn this usage into actual monetary amounts that you ask people to pay. And this is the part where I would like to hand over to Ralph.
Oh my God. Yeah, I'm coming. So thanks a lot. And yeah, that's the clicker. Mm-hmm. All right. So, demo. Oh, I can click, right? Good. So, the slides get fancier and fancier, as you can see. So, but the question now is, how do we actually make use of that, the metrics data that in the aggregation we get through SPOUD's Kafka cost control service at Migros? So, how can we actually make use of that data in a sensible way where we actually do a fair cost distribution, right? So again, Migros is a large retailer in Switzerland. I'm working on the central Kafka or enterprise Kafka platform team there for a good 2 years, which is basically some dedicated Kafka clusters, some software written around them, including cost control, and a team of engineers. And it's already being used, you've seen that by a lot of teams and users. So our idea of being fair with regards to cost distribution is basically usage-based, right? But we found out that there's many more decisions and assumptions that you have to take. So it has to be in some way opinionated, and that's the blue bit here. Can I do something? No. Anyway, so what we also want to do is not just to have this fair cost distribution, but also to incentivize people to use our platform correctly. I mean, Alex was also hinting at that, so that, for example, producers have to think about how to use compression and things like that. So we also want to empower or to incentivize teams to use Kafka more wisely and not just use it and do whatever they want. So what do we know now? We know the total costs for Confluent Cloud, right? So we get like a monthly bill. We can see how much data has been, how much do we pay for the producing, consuming, for storage, and for the actual cluster that we know. That's not much. We know the total service costs. So we know like the Confluent Cloud costs plus salaries and Kubernetes and all that other stuff. And we know the usage metrics per client through Kafka cost control, through the service that Alex has talked about. Now, let's have a look at an example to make this a bit more concrete. So again, we know the consume traffic, produce traffic, storage, the cluster cost per month. That in this example, I mean, that's a made-up example. It's a little bit realistic, but not completely. So in this case, like we have $2,000 that we pay per month for consuming, 1,000 for produce traffic, so we have 1,000 for storage. And because it's dedicated clusters, we pay a lot for the clusters, 11,000, so it's 15,000 all in all. We have 50,000 all in all, so that's the 15 plus all the salaries and stuff on top. And by Kafka cost control, we know how much, how was the usage of the Kafka cluster. So how much did we consume, produce, how many partitions have we used, and so on. And we also know that per app, right, or per client, right? So we have an example here. For example, this client used, it consumed 500 gigabytes of the 50 terabyte in total. So these are the numbers that we have. Now, we do 4 steps. One step is, we call it consume, produce, split. I can't do it right. Right. So the idea is to opinionated, in an opinionated way, distinguish or like put these costs into 2 buckets, the consume bucket and a produce bucket. And we say, I mean, the simple way is here, so the red costs, that's the consume cost, that goes into the consume bucket. And in the produce bucket, we not just put the produce traffic, but also the storage and the cluster cost, right? And then if we put this together, we see, of course, the produce cost is more expensive. It's 87%. And yeah, and we use that split basically, so that percentage, that share, to also apply it to our, to the total service cost for the Kafka service. Now, things that are not easily visible. We do the same for the actual metrics that we get, right? So we again say consume is just consume. Produce is not just produce traffic, but also the storage and the partitions, right? And the idea is to do incentivization again, right? So we want to have the producers take responsibility because they are upstream, they can decide how they choose the retention policy, the retention time, the number of partitions, and they are important here. And if we say that they are important, then they also have to take up more responsibility than the consumers. Okay, step 2. What we do next is we calculate the share, so the usage share per client or per application using our cluster, right? So again, for consumer, that's easy. That's just what the client has consumed divided through what we consumed overall. For produce, we actually do a bit more complicated calculation. In a sense, we add to the calculation how much does this cost on Confluent Cloud, right? And so that means the green part here gives us how much has the client produced, and how much is the share of this producer or of this client of producing costs on Confluent Cloud. So in this case, in the example, for the example numbers, we have like 1% usage of the example client for consume, and we have 2.6% produce share here, mainly determined by the partitions, because that's another assumption. We basically equate the number of partitions with the cluster cost on Confluent Cloud. And that's the determining factor here. Okay. Now, we are almost done. Step 3. So how do we actually make use of this share that we calculated? So we now know a percentage of how much consume cost share this client had and how much produce cost share. And now another assumption. So we say each client has to pay that. It has to pay, first of all, its consume share times the total consume service cost. I mean, that's easy. Second part is a bit weirder, maybe, harder to understand. So we also say that according to how much the client has consumed, it has to participate in the produce costs. Right? So it has to actually pay, so the consumers actually pay 2/3 of the money for produce. And that's a bit what Alex was alluding to before. That's a bit of cross-charging. Not really, but at least we use this to avoid parasitic consumers, which just consume and not produce any data, not give us any data products. Okay, and thirdly, the producers, according to their produce share, they also pay 1/3 of the produce costs. That's our calculation at the moment. I mean, very opinionated again. And again, it's very important here to incentivize. So we want to incentivize our clients to produce data, to participate in giving us data products, not just like this parasitic behavior of just consuming, right? Yeah, so here's an example. That's for the example that we talked about before. That's a more interesting example where we have a client that's only consuming, right? So it has 2% share of the consume traffic cost. And you can see in the second number here that this client, because it's only consuming, has to take part a lot in the produce costs, right? So it's basically, it's paying some kind of a tax, right? The consumer is paying kind of a tax because it's just consuming and not producing and giving us any data. And you can also see if there's clients that basically just give us data, then they pay less, right? So they pay less than $300 here if they have like 2% produce share. And yeah, that's the idea. I mean, these are basically very opinionated, very arbitrary decisions that we have taken. It works for the time being, but you can basically improve this radically still. It's just something which nobody has really thought about before. Step 4 is we also want to add a last bit of fairness and a last bit of incentivization. We do some smoothing. So because we want to have teams which use Kafka to the fullest or very heavily, we want to basically let them pay a bit less per gigabyte, and those who just use it a little bit to pay a bit more per gigabyte, essentially. And for that, we use some kind of smoothing. We started with weighted redistribution. That works quite fine. And again, it's incentivization, right? We want to incentivize people to use the platform, right? And if they use it more, then they pay basically less per gigabyte. Here's an example. So I used another AI for different names for the apps to mask them. But you can see, I think I can also use this. I never use it. Yeah, okay. So you can see that here are the metrics. So this here is the heavy consumer from before, the vast elephant. So they have a lot of partitions. so lots of produce costs in our sense. They end up with $14,000 here, or francs. But due to the smoothing, it's almost, or it's even less than half. Right? And on the other hand, if you look at someone in the middle here, this one, Antwerpia Katalog. So this, according to the calculation, they would have to pay 118, but the smoothing gives them more, almost 3 times. So that's kind of what we did, right? And that's it. So you can see, have a look at Kafka cost control on GitHub. So that's the tool which we use. There's another cool talk from last year's Kafka Summit, which goes into the same direction. That's this one here. Keep your Kafka cloud costs in check with showbacks. And yeah, so, I mean, you can come back or we can take questions. Thank you.